So let's look at times that those guidelines fail us. For number 14, we have tangent of 3x divided by secant of 3x. Well, yes, tangent here is odd and positive because it's raised to the first power, but I can't save a secant tangent because secant's in the denominator. Since I have this rational expression, it's honestly best to convert this into sine and cosines to handle this problem. So I know tangent is equal to sine of 3x divided by the cosine of 3x because tangent is sine over cosine. And I'm dividing it by the secant, and I know that the secant is really 1 over the cosine. But if you're dividing by a fraction, that's equivalent to multiplying by the reciprocal. If I multiply by the reciprocal, I'm multiplying by cosine of 3x. Well then, this cosine of 3x in the denominator and that cosine of 3x in the numerator cancel, and you only have sine of 3x dx. Well, I can integrate sine of 3x dx. That's basic form. I notice that I have a 3, so I know I'm going to multiply it by the reciprocal of the coefficient of that linear term, 1/3. And I know that the integral of the sine of u du is negative cosine of u plus c. So in this case, that's going to be negative cosine of 3x plus c. Well, 1/3 times a negative is negative 1/3 cosine of 3x plus c. What about number 15? Well, number 15 also has tangent that's odd, but I can't save a secant tangent yet. I will need to save a tangent and convert my other tangents into secants using that Pythagorean identity. So I come over here and I rewrite this as tangent squared theta times the tangent of theta d theta, because tangent squared times tangent is tangent cubed. Then I use that Pythagorean identity to rewrite tangent squared. Well, I know that tangent squared is equal to secant squared theta minus 1. Well, now I distribute tangent squared to each one of these because I still, remember, would need a secant tangent in this case. When I distribute, I end up with secant squared theta tangent of theta minus tangent of theta d theta. Now, this right here, the integral of tangent of theta, that's basic form. I know how to integrate that. Over here, I have two options. I have secant squared, and I know that the derivative of the tangent is the secant squared. I can make myself a power of the tangent, or I could rewrite that as the secant times the secant times the tangent and make myself a power of the secant. Since I already have secant squared, I'm going to decide to make that a power of the tangent, but I'm going to split this into two separate integrals so it's easier to deal with. This guy over here I'm going to rewrite as tangent of theta times secant squared theta d theta, and then minus the integral of tangent of theta d theta. So here if u is equal to the tangent of theta, the derivative du would equal secant squared theta d theta. So this guy right here is just u du. And then if we integrate this guy over here, the integral of the tangent of theta d theta is negative natural log of the absolute value of the cosine of theta plus c. Integrating over here, we end up with u squared over 2, and then minus a negative is plus that natural log of the absolute value of the cosine of theta plus c. And then finally getting out of u's and back into thetas, we'd have tangent squared theta over 2 plus the natural log of the absolute value of the cosine of theta plus c. The last thing that we're going to talk about in this section is products that are involving sine and cosine. And really, we're looking at products where the argument of your trig functions is not the same. If they're both x's, or they're both 3x's, or they're both 5x's, or they're both 4x's, etc., if they're the same, we know what rules we use. We use the rules we talked about before. But if they're not the same, we have to use these product to sum identities. Now the product of some identities said the following. If you have the sine of mx times the sine of nx, that's always equal to 1/2 times cosine of m minus nx minus cosine of m plus nx. The sine of mx times the cosine of nx is 1/2 times the sine of m minus nx plus sine of m plus nx. And finally, the cosine of mx times the cosine of nx is equal to 1/2 times the cosine of m minus nx plus the cosine of m plus nx. For number 16, we're going to be using this purple highlighted formula. In this case, my m, the coefficient of x here, is 3, and my n, the coefficient of that x here, is 5. So plugging it into this formula, I know that this is just the indefinite integral of 1/2 times the cosine of m minus n times x. So in this case, 3 minus 5 times x, or negative 2x, and then plus the cosine of m plus n times x. So in this case, 3 plus 5, or 8x. Well, the first thing I notice is that I have this 1/2, and that 1/2 is a constant multiplier, and it can be pulled out of the integral. The next thing I want to talk about is this right here. Cosine is an even function. What does that mean? Well, that means that the cosine of negative theta is equal to the cosine of theta. So we are going to rewrite cosine of negative 2x as cosine of positive 2x, and we're going to integrate it as a cosine of positive 2x. Think of it this way. You could rearrange these terms where your m minus n is positive, so you would always have just an m minus n that's positive. Now if I integrate, well, this is linear, so I know I need to multiply it by the reciprocal of the coefficient of the x term, so in this case 1/2, and the integral of the cosine is sine. Same thing here, linear multiplied by the reciprocal, 1/8 sine of 8x plus c. Last and final step is to distribute that 1/2 in the front, and we're looking at 1/4 sine of 2x plus 1/16 sine of 8x plus c. Last one, number 17, sine of 4x times the sine of 5x dx. Well, that's going to use this green formula over here. In this case, my m is equal to 4 and my n is equal to 5. So following this formula over here, we can rewrite this as the indefinite integral of 1/2 times the cosine of m minus nx. So 4 minus 5 is going to give me negative x. And then minus the cosine of m plus nx, in this case 4 plus 5, or 9x dx. We know that cosine is an even function, so we rewrite this, also factoring out that constant multiplier, as the cosine of just x minus the cosine of 9x dx. Now we integrate. The integral of the cosine of x is just the sine of x, and the integral of the cosine of 9x is 1/9 the sine of 9x plus c. Lastly, we distribute the 1/2, and we get 1/2 sine of x minus 1/18 sine of 9x plus c. That's it for trigonometric integrals.